Hi. So the today's course name is the Basic Electronics Engineering and course code is the IC 201 EC 101. Myself Dr. Vishwarup Niyogi from JS College of Engineering, and I am the associate professor and the head of the Department of Electronics and Communication Engineering department in this institute. And this particular course is the contact hours is the 36, and first we have to know about the course properly and what the part we want to discuss today, and after then definitely go for the next step. So first we go for the next, that is the prerequisite of this particular subject. The basic course in the electronics and communication engineering progress from the fundamentals of the electricity, direct current, DC, and also AC also, and also the circuit and series of the parallel circuit, and to the study of the active passive components, the Ohm's law, Kirchhoff's law, KVL, KCL, amplifiers law. These are the prerequisite, and the today's topic is very important, that is related to the transistor. We are entering the bipolar junction transistor. So for that reasons, this is very essential to know about all these things. If you have no any idea about these things, it is very much trouble to you to understand. So this is prerequisite, then you can understand the next topic of you. And next is next step is that the course outcome, that what you can study, what you can get the outcome from here, the study of p-n junctions, tidal diode models, and the circuit analysis applications of the diode and special diode. Learn how the operational amplifier is the model analyzed, and the op-amp circuit and all those things. The study of the concept, the both positive and negative feedback of the electronic circuit. The develop capability of analyze the design and the sample circuit of containing non-linear elements such as the transistors. So this is directly connected to uh, this particular CO is directly connected to this today's topic, that is a development capability to analyze the design and simple circuit of containing the non-linear element such as the transistors using the concept of load line, operational point of the incremental analysis, and all those things. Basically the transistors, in case of transistors, these are very important, the course outcome, that through these transistors we can very easily understand about the IC. This is the basic concept of the IC, how the IC is constructed through the transistors and all those things. So this is very important. Now this is the COPO mapping, the course objective and PO mappings is there, which is very important. That's why as per the Washington Accord, this is very much mandatory at present now in India for any kinds of engineering course and all those things. So this is a representing in here. So today actually we go for a very important fundamental things, that is the transistors. Transistors is basically the transfer register concept. First we go for the uh, inventions that the charge change the world, that is you show that the concept of anode, grid, and cathode, and from there the concept of that is the triode concept. This is the triode concept, and from there another new concept is introduced, that is the transistor, that is the transfer registers concept, that is the transfer registers concept. Why it is called transfer register and all those things, I will come to that matter. Before that we just study about these things and learn about these things, then we can understand about that why it is called transfer registers. Now this is the Aniak. Aniak is the electronics numerical integrator and computer. This is the fast computer. You show this is the fast computers. uh, this is the pictures of Aniak. So in this particular fast computer, these are all developed by the valve, and all the valve you show there is inside of there is all the valves are there. Through this valve, this computer is developed, and at present now the computers is a very cheap level, very small level in your mobile, where if you're showing this video from you by your computer or mobile, that is also very small computer, and you know that is the mother of the computer, that is the Aniak you just study in here. So at the time of that time, this was as a developed, that is the ENIAC, that is the full form is the electronics numerical integrator and the computers. Okay, so this ENIAC, to know about this ENIAC, to know about these things, how the concept is coming, so for that reason the transistor study is very much essential for you. And you show there is a pictures in the previous date, that is the previous slide, that is the pictures of the triode, that is the triode valve concept, and that is the transistors concept is here. Okay, so these are the concept of the transistor. So I'm going to the microchip, and this is the silicon wafer. This is I hope that you have already studied in my previous videos, and I'm sure this is the Intel chip, and inside of that this is called the microchip. And inside of this particular microchip, you show that silicon wafer, there is a, the picture is in here, that is a microscopic picture. These are all silicons, so silicons developed, and inside of this the transistors, all the transistors are connected, and all these things like that way, it is working. So know about the transistor and all those things. This is mandatory to generate the chip level concept. The transistors is very much essential. To know about the transistors is very much essential for you. So before that I'm coming to this is suppose this is a intrinsic semiconductor. Intrinsic semiconductor means that is a pure semiconductor, pure silicon wafer. Silicon wafer means that is the wafer, uh, you know the wafer, one of the eating things that it looks like that, that's why it is called, this is representing like that, this is a wafer, this is a wafer types of things. And in the wafer, the at the same times we are doping the wafer by for the p type, n type and p type, so or n type, p type and n type, so that the wafer is converted to the PNP junction or NPN junctions. Okay, so that is actually that is, you show there is a doping concept, that is p, it is n, or it is n, or it is p, it is n, it is p. Okay, so if I'm just uh, doping by this, by impurity this and just at the same time and the same wafer, otherwise it will not happen, then it is developing a p type, a n type and a an n type. So PNP junctions is created. If in case of this n, so it should be a aluminum, and in case of this it is, suppose it is the phosphorus, and it should be aluminum, because this is the trivalent, sorry, I'm absolutely sorry, this is the aluminum and this is the p, phosphorus, that is the pentavalent, and this is the trivalent, and that is also the p, that is the pentavalent. Okay, so like that way we just inject and develop the NPN transistors. And you show uh, this is called a BJT. Why this is called BJT, bipolar junction transistors? Because in case of N, there is a majority carrier is the hole. Sorry, there is a majority carrier is the electron, and P, there is a majority carrier is the hole. There is also electron. This both hole and this electron, these both are working for, hole and electron both are working for the purpose of amplifications, purpose of the activity. So for that point of view, it is called the bipolar. Both are working togetherly for the any kinds of purpose. That is why it is called bipolar junction transistor. That is why it is called the bipolar junctions transistors. Okay, and you show there is we just introducing some battery and just connected to the positive with that and the negative with that, and it is also negative with that and this, then what happened, you show like that we just go for the doping, we go for the biasing. Okay, that is called the biasing. We are introducing the voltage for the purpose of us, that is called the biasing. Now I go for one very important thing, that is the transistors is called transfer resistor. Why transistors is called transfer resistor? That things we want to know. That suppose we are considering that transistor is that is, suppose it is created the transistor that is P, pipe type material, PNP. Okay, so suppose I want to introducing one electron, I want to pass one electron through, suppose I want to pass one electron through this pipe. Okay, suppose I want to pass one electron through this pipe. Okay, very good. So this is the p-type material. So here the majority carrier is a hole, here majority carrier is the electron, here majority carrier is the hole. Okay, so first time here hole is attracting this electron. Okay, very easily. And to pass this electron here we have to give some pressure, we have to give some voltage bias. So that is called a biasing. That is called the biasing. Okay, so we have to give some voltage in here to pass this electron through this, and when it's coming to this particular junction, here it is the N and here it is the P. So P is try to attract this electron and N is try to repel this electron. P is try to attract this electron and N is try to repel this electron. So for that reasons one resistive effect is there in between these two junctions. Okay, one resistive effect here in between these two junctions. Okay, very good. One resistance is there. Now coming to, suppose this electron passing here and coming to this particular and want to overcome this barrier. So when the PNP, when this electrons coming to here and want to passing these particular junctions, at that time what happened? You show the electron is try to repel this electron and hole is also try to attract this electron. So here also one resistance which is comparatively lower resistance than this. This R is always greater than this small r. Okay, so you show a transfer of the resistance, transfer of the resistor is happening in this PNP concept. That is why this is called the transfer resistor concept. That is why it is called transfer resistor concept. We can go for it vice versa. We can consider it is in the N, it is in the P, it is in the N. Like that way also it can be possible. Okay. So this is the concept of the transfer resistor. This is the concept of the transfer resistor, and this is the concept of the biasing. That's I want to pass a electron from this side to this side. For that reasons I am introducing some voltage. We are applying some voltage, applying some force. What kinds of force is that? It electromagnetic force. What is electromagnetic force? Electromagnetic force is nothing but a voltage. So that is called the biasing concept. We are introducing the biasing in here. Okay. Sorry. So uh, so this is called the PNP and NPN concept of the transistors, and we can understand that how the biasing is happened, how the concept of the biasing is happened, and why it is called transfer, why it is called transfer register, trans registers. These both taking the transistors. Okay, next we go for one very important things, that PNP and NPN transistor representations. So sorry, so for that reasons we just go for a PNP and NPN transistor representations. And this is the NPN transistor, and this is the PNP p transistors. Actually what happened, this is the base collector and this is the emitter. This is the base, this is collector, and this is the emitter. What happened, uh, actually, the base collector and emitter concept is there. Base collector and emitter concept, actually, okay, actually what happened, the base, there is three terminal in the transistors: collector, emitter, and base. So basically, uh, arrow is present in the emitter and it is from P to N. You show there is a diode concept P to N. There is also a diode concept P to N. This side P, this side N. This side P, this side N. This side P, this side N. So P to N. Directions, that means in case of transistors it looks like that, and diode and arrow is from P side to N side. Arrow is from P side to N side. In emitter side there is a arrow. Arrow is present. What is the directions of the arrow? From P side to E side, P side to N side. You show their base is P and this emitter is E. Emitter side is, so P to E, N side, and here it is the emitter is P and A, base is N. So from P to N, so this side is that arrow. Arrow is the this side. So this is the concept of the transistors and how to develop the transistor. So today's lectures, what we have studied first, that how the transistors is developed, and the year, that is the CRT, that is sorry, that is triode. From the triode, the transistors concept is coming. That things we have first of all representing. After that, we know about the Aniak, that is the electronic numerical integrator and computer, that is developed in that is for the fast computer, and inside of the fast computer there is some valve related things. And at present now, for the transistors and transistors inventions, the all these things are in your hand, that is in the computer and the mobile. This is the embedded technology. So basic of the embedded technology is incorporated with this particular transistors. And you show there is a Intel chip. The first Intel chip is here, and also the silicon wafer in here, and also how the silicon wafer is looks like by the microscopic range. That things we want to representing in here, and like that way. Uh, and uh, and then we just understand about the doping. We just understand about the doping concept, doping, and how we can make a PNP or NPN transistors. That's we are creating the NPN and PNP transistor in here in P and N, and after then we just how it can biasing, that things also understand, and then we can understand about all these things the matter. Now I hope you can understand about that. So thank you very much, and I definitely go for the reference, because reference, without reference it cannot be possible to develop this type of lectures. I'm taking some material from here, that is OWI, this particular thing, and pattern.com, www.pattern.com. I would like to acknowledge this website, and you can able to visit in here also, that get some material from there. I am also taking some material, so that's why I am representing reference. So I hope you can understand this thing, and it will be beneficial for you. So thank you very much.